All right. Hello, everyone. Welcome back to Comp 2160 Programming Practices. I hope that you all had a great weekend. Despite the smoke, can anyone actually stay up late enough to go see the aurora? Did anyone go see it? Yeah? Where did you go to see it? To Grand Point? And how did it look? Yeah? Did anybody else go out of the city to see it? Did anyone go on their balcony and see it? Did you see it? Were you able to see it from your balcony? Yeah. Okay. I went out in my backyard at about 10:30 at night, and like, this is me desperately trying to stay awake. And I couldn't see anything. I saw what I thought was like a faint pink glow, and I pointed my phone at it to see, like, can my phone pick it up? And yes, there was something, but it was also 10:30 at night, and it wasn't really ready to happen. The other thing I did on the weekend that I had some fun doing was I went to Activate. Has anyone been to Activate before? Yeah, okay. I went there. I've been there a long time ago, like pre that big thing that happened that nobody wants to talk about anymore. And I had a lot of fun there. But this time I went with my son, and my son is 8. And I don't know how many 8-year-olds you know, but 8-year-olds have a lot of energy. They have a lot of energy. And like, I was there with my son and my partner, and we were just like going from room to room to room to room to room. And I felt great that day. And then for the rest of the weekend, I felt like a very old man. I don't think that I'm not fit. Like, I ride my bike here from home. I commute on bike. And I live a little over 20 kilometers away. So I ride my bike a lot every day. But I still felt awful after that. Yeah. But it was still fun. And yeah, so I hope that you're all doing okay. I'm doing okay. Today, what I want you to be able to do by the end of today's lecture is we're going to focus on these 2 specific learning outcomes. These are the really high-level learning outcomes from our course. Recognize potentially risky programming techniques and how they differ in different high-level programming languages, and write safe code in a programming language that makes it difficult to write safe code. We're going to focus on 3 smaller parts to all of this. So we're going to keep seeing these learning outcomes over and over and over again, and we're going to be looking at small parts of it throughout the term. The 3 things that are the small parts of what I want you to be able to do are declare, initialize, and use strings in a C program idiomatically and safely. We did this with arrays last week. I want us to do it with strings this week. Strings in C are just dumb array of char, but we use them for different things than we use arrays for. Like, we do a lot of stuff with strings that really doesn't kind of represent arrays in general, so I want to talk about strings in C specifically. I want you to be able to pass a string to a function and then return, and I'm putting in quotes here, return information back from a function. This is something that you do in Java and Python frequently. You will have a function or method that takes as input something, and then it will return something back. We've got functions like this in C so far, but we're going to try to do this with a string today, and we're going to very quickly find that we can't even compile our code. So we have to do something different. And that different thing is to take something in input and then put something into that input and then send things back that way. We'll take a look at that in a little bit. I also want you to be able to get line-based input from standard input with a function that's called fgetS or fgets. Once we've got this, we are now at the state of you can complete the assignment. Once we've got this, you're at the state of you can complete this assignment once we get to fgetS. We're going to take a look at that. This is going to be related to declare, initialize, and use strings in a C program idiomatically and safely, because we're going to do some stuff with fgetS that results in kind of strange looking output and behavior, but we'll try to solve those problems when we get to that point. So Let's first start by taking a look at some of the stuff that we did last week. Most of what we were doing last week was focusing on our command line environment. So we spent a lot of time thinking about creating and navigating folders, choosing a text editor. Everybody using Vim? Yes, yes, good. Everyone's using Vim. Yes, good, good. You can keep telling me that, and then when you come to my office and show me your code in VS Code, you can just say, it's just a skin for Vim. It's okay. We spent a lot of time on that. We've spent a lot of time talking about connecting to Linux systems on the U of M campus, so Aviary specifically. We talked about using Handin to be able to submit your work for the assignment. There were a couple of posts on the course forum that were related to sending data back and forth. There was one anyway. So I posted about doing that SSH keygen thing to get passwordless connection to Aviary. Connor responded to that with something. I forget exactly, but I thought she responded to something about that. And then there was another post about transferring data from Aviary to your laptop. And there was another post that I made about that that's kind of like you can pull entire folders from Aviary using FCP. So take a look at the discussion forums if you haven't done that. We also started doing some basic C programs, and the goal here with the basic C programs was beginning to compare to Java specifically. So I can confidently say that you all have some experience with Java, and so I want you to be constantly thinking about how is this different from what I'm doing in Java? How are these things connected, and what makes one language do this better or differently than the other? But some of the superficial differences and some of the things that are subtly different than what we have in Java was import versus include. So import in Java gives you access to the classes that you're importing. Include in C is really just about doing forward declaration of functions. We will revisit this again more, but it's mostly about getting those function declarations so that you can use them. So calling things like printf. Primitive data types, superficially at a high level, they're all effectively the same between C and Java, but then we've got these weird things like in C, it's really just 0 and non-zero that's Boolean as opposed to literal true and false. Although we can get something that looks like literal true and false with stdbool. If we go deeper into C versus Java, then we can start thinking about how many bits each of these different data types represent. And then when you get to later courses, you can use specific libraries that will say, I want exactly this many bits regardless of which architecture I'm looking at. We started doing arrays and strings. We focused more on arrays than strings, but we were doing them both kind of at the same time. In C, a string is just a dumb array of characters. We were thinking about things like best practices here. So how do I declare an array with a size using this preprocessor directive number define? And then functions versus methods. So the main thing here is really that we've got functions that can accept input and return output, but they're not operating on an object. They're not operating on a class of an object. They don't have state in the same way that methods do in Java and other languages like that. Let's do a little quiz. I'll give you like 5 more seconds to join and then I'll start. Okay, the code should stay up at the top, so you should be able to keep joining if you're still getting joined right now, but here we go. Okay, awesome. I want to write this function find the location of a specific character in a string, what kind of loop should I use? So this is going back to that best practices document, that one part that I'm focusing on here. Make sure that you're choosing the right kind of loop for your intent. Basically communicate to the person that's reading this what the purpose of this code is. A for loop, because strings are dumb array of char, that's a fair idea. That is a fair and reasonable thing to pick. When we're iterating over an array, by default, my mind always goes to for loop. Always goes to for loop. That's my default behavior when I'm iterating over things in an array. That thumbs up button is just like going like this right now. That's my default. The context here is I want to find the index of a character. And in that kind of thing, that's a linear search. We're going back to 1010 here and thinking about different kinds of searches. This is a linear search. It's not sorted. I can't do binary search. I can't stop in the middle. I could stop in the middle to say that I've actually found this thing. So in this case, I want to say that I'm going to look at every character before I find the thing that I want. So this answer by itself here, because it's a dumb array of char, that's not the right reason to choose a for loop. The next one, a for loop, because I need to inspect every character, this is a reasonable thing to choose. In this case, the H for happiness in university doesn't exist, right? Yes, haha, okay. So we have to look at every single character before we find out that I'm going to return -1. This is not in that string. I cannot find it. So I have to apply this operation to every single element in the sequence. I must do that. It could be that we've got an H right here. And it would be reasonable for me to say, well, okay, I found it right here, but I'm just going to keep on going and checking every single character after that, but I'll still just return index 0, regardless. I'm going to go through this dumb process of look at every single character. I found it in the first spot, but I'm going to keep looking at every single character. That's not optimal. You're wasting a bunch of cycles. The amount of time that you're wasting here is microseconds, so it's kind of irrelevant, but this is a reasonable choice. This part, this is the one that I would pick for sure, a while loop, because the event is finding the character. I've found it. I can stop iterating. I can set a flag that says stop looping on this thing. I'm going to exit the loop and I'm going to return the index right away. The opposite case is it's not here, and that's why these two are related. So a for loop because I need to inspect every character, and a while loop because the event, is not finding the character. I do a linear search and I get to the end. I've inspected every element. It's not there, but I've looked at every character, whether I do it with a for loop or a while loop. This problem does require a loop. I think we can all agree on that, and I'm happy that nobody picked that. Is that okay? Any questions? Good. Okay. Okay, awesome. So the little code fragment here, it never occurred to me that it would make the picture disappear. You don't need to hear my voice. That code fragment there declared 2 arrays, and it declared these 2 arrays by just hard coding 10 and then 13. So this one for sure, magic numbers. I have no idea what those things really mean. Location of brackets or braces? Nah. The braces were consistently placed in the same places, so on the next line and then matching the one at the bottom. Uninitialized variables, we had 2 arrays here. They were both completely uninitialized. To solve these 2 problems that we have here, The first one is magic numbers, avoiding magic numbers, especially with array sizes. Use number define. Use preprocessor directive to say this is the size of my array. In terms of how long it is, the name might be even something like name length, and then you just give the fixed number, but you're giving a name to that fixed number. Uninitialized variables, in the array declaration, I can assign that equal to, and then that curly brace notation 0. So assign everything to 0, and that will fill the array with zeros. Bad variable names, arguably that was correct because array is a terrible name for a variable. Name is an okay array, an okay name for a variable, but array is maybe not the best name. This code does not compile. The code does compile, but it doesn't compile without warnings. I'm a little bit uncertain about definitely a student. Okay. We got 2 more questions. An array of char. Good, excellent. If we're being hyper technical here, this is not correct because an int has a different size than a char. And so it's not technically this. You can represent characters as numbers in C, but they are not the same size as integers. This is definitely the correct answer. Here's the last question. Okay, good, good. So 3 people do remember that little trick of just CD and nothing else. That is a valid way to get home. Another valid way to get home is with the tilde character. Dot dot here is up parent, yeah, dot current. Why would we ever do that? Would we? I don't think so. Go home. This could be if you declare this as a variable and you put a $sign in front of it. And maybe I should have made this a correct answer. I'm really sorry to the one person who selected this. Let's take a look at our leaderboard and see how definitely a student did here. Congratulations, Squeeters. All right, okay, cool. I would like now to, again, this is not a C programming course, but we're going to spend the entire class today doing C programming. I would like to write a program that works with some strings in C. We did length of strings once, but I'm going to quickly type it in again. I'm not going to narrate too much when I do this. I'm just going to type it in. These two, compare strings for equality and copy strings, I do want to go through these ones a little bit more slowly. Please type along when I'm doing this. I really encourage you to type along when I'm doing this. This is going to be a fairly comprehensive use of strings for the purposes of what we need to be able to do in this course. So let's get down and start writing this out. At the back, is this font big enough for you? Can you read it okay? Tell me when to stop. It's not getting any bigger. I'm not looking at my screen, I'm looking at you. Is that good? Okay, thank you. So right now, I'm in my Comp 2160 lectures directory that I created in my user directory. I'm going to do one thing here right now because I'm going to be doing this a lot. I'm going to be starting from an empty C program, and then I don't really want to type in number include and int main every single time I do this. So I'm going to start here by writing a little template. So template.c. I'm going to stop narrating what I'm doing in Vim unless it's something that I don't think I've done before. I printed these out, so if you forgot yours at home or if you didn't ever get one, please feel free to come and grab one at any point. But I'm going to do my best to stop narrating Vim and then only say something if I'm doing something that I haven't done before. So I'm going to include stdio.h. I'm going to include stdlib.h. And I'm also, for now, going to include stdbool.h. Including stuff that you don't use isn't really going to affect anything. It's not going to change the behavior of your code. In the long term, I'd say don't do that, because including stuff we're going to see adds a ton of code to your code. In the long term, don't do it, but for now, it's fine. Let's just do it. We'll start with this template. I'm going to say int main. And because I'm not going to be typing this out every single time, I'm going to do that longer hand thing. So int argc char star star. I'll do 2 stars here, argv. I'm going to say return exit success. I'm going to save this. I'm going to put a new blank line here. I'm going to save it again. I'm going to pop open another terminal on my side just so you can keep seeing this if you want to keep working with it. I'm going to change into my comp2160 directory. I'm going to change into my lectures directory. I've got this file here now called template.c. I'm going to make a directory for today's lecture. I'm going to change into that lecture. And now I'm going to copy that template. So I've saved it. I'm going to copy that template so that I can just start working from this template. Now I don't have to write this over and over and over again. I can just copy it each time I want to start. Yes, please.
So the last time you talked about there being a chart, what were the 2 stars? What do they point to?
That's a really good question. So the question is, what does, I'm going to summarize this for you. What does star star mean? I think that's ultimately what your question is. Char star is equivalent to char array. It's not. It's not, but for what we're thinking about right now, they are the same thing. In C, a string is a dumb array of characters. A pointer can point at an array. That's kind of what we're at. A pointer to a pointer is, the synonym here is, this is an array of arrays. This is an array of arrays of characters. So in Java, what we had was string array here. We said string square brackets args. String square brackets args had a length. It had a dot length because it's an array. That's this int argc here. That's where we get that from. The char star star argv is now going to be the array of strings that I'm able to work with. We're not touching that for quite a while, but that's the answer to that question. Okay. So I'm going to copy this template. So cp is the command to copy from my parent directory. And I'm going to call it strings.c. This is going to copy templates into a file called strings.c in this directory. And I'm going to start editing strings.c. I'm going to delete these 3 lines up here. And what I want to do now is, again, I'm just going to quickly go through typing out the string length parts. When I'm working with functions in C, the first thing I need to have is some forward declarations. So I need to declare my functions before I am able to call them or use them. I'm going to call this one string length. It returns an integer and it takes as input a character array. So string underscore length, char string, I'll call it. I'm going to declare a string here. And what I'm going to say is name is equal to Franklin. I want to pass this to string length, and I want to print it out. %D is for digit decimal number. This is for a whole number. New line, name, and length. Is everyone done with template? Can I close that one? Thumbs up if you're done. Okay. So I'm going to close this. And I'm also going to zoom in here. So again, I'm using tmux. This is a terminal multiplexer, so I can have these two things open side by side. I'm going to zoom in here by pressing Control A and Z on my keyboard just to make this fill the whole screen so that I have a little bit more screen real estate to work with. I'm going to continue writing string length. So now I'm going to declare string length. I'm going to define string length down here. And what we learned last time was that strings are these null byte terminated. They are null terminated arrays. Null in this case is that special character \0. When you were in Comp 1010 and Comp 1020, you may have seen this idea of partially filled arrays and sentinels. Yes? Yes? Okay. In our case, a character array, a string in C is potentially a partially filled array. Yes, yeah. What's a sentinel? That's a good question. Okay, thank you. Okay, do we all know what partially filled arrays are? Yes, okay, so sentinel is if you've got, I'm going to write this in Java, so I'm going to delete this line right away. I'll put a comment here. Int positive numbers. If I say new int, let's say that I'm going to declare an array that has 10 spaces in it, but I'm only going to fill up to the nth element. I might say that positive numbers at position 5, so this is partially filled, is equal to -1. This is a little flag that says to me, stop. This is the end of this partially filled array. That's what sentinel means to me. It's a marker it's a special value in the array that says this one is the end of that partially filled array. Does that make sense? Okay.
So, with like, there's null terminated strings right here are kind of like, the null termination is kind of like the sentinel.
The null terminator is the sentinel, yes. Yeah. It says this is where this string ends. Remember, we could just keep trucking on past it, and we don't get array index out of bounds exception. We just keep going past the end of it, and it doesn't care. That null terminator says, this is where you should stop. This is where you should stop. It's a sentinel. It's a guard that says stop here. Halt. Yeah. Okay. So I'm going to say int length is equal to 0 while string at length does not equal the null byte. Length plus plus, return length. So this code is now inspecting every character in the array that we pass to it. And when it reads the character element that is the null byte, we will stop the loop. That's the event that we're stopping on. And then we'll return the number that we counted up to here. I'm not going to close this. I'm just going to de-expand it. I'm going to change into lecture 5. I'm going to clang w all strings.c-o strings. For completeness, when I was feverishly typing this in last class, I put the square brackets in the wrong place. So forgive me if I made you type something that was wrong and then like, it's not compiling. I don't know why it's not compiling. Please forgive me for that. The correct placement of the braces is just at the end of the name of the variable. So if I say /strings here, I get my name is Franklin. The length of this is 8. I'll give you 15 seconds to catch up. Okay. I'm going to go to the top. Again, GG, lowercase g, twice in Vim takes me to the top. I want to compare strings now. Comparing strings in C, if we're thinking back to Java, we've got this nice string type. We can call .compare_to, we can call .equals. I'm looking more at .equals than compare_to right now. Compare_to lets us return an int, and it's positive, negative, or 0, but that's kind of complicated, and I really just want to focus on, let's check for equality between these two things. So I'm going to say that this is a function that's going to return a Boolean type. It's going to take as input 2 strings. I'm going to call it string compare. I'm going to take 2 strings as input, and I'm also going to take their length as input. In C, our strings are just dumb arrays of characters. When I'm working with arrays, I want to do my best to make sure that I'm taking as input how many elements are in that when I'm working with arrays and functions. So I'm going to say here char string 1. These are poorly imagined names, but in the context of I'm checking one string against another for equality, string 1 and string 2 are perfectly cromulent names. I'm going to say int str1 length. I'm going to make this bigger again, so I'm going to expand it. I'm going to say char string 2 and int str2 length. So here's my forward declaration. It returns a Boolean. True means they're equal to each other. False means that they are not equal to each other. Args, string 1, the first string, str1 length, the length of the first string. And then return true if equal, false otherwise. False if not. Okay. So there's our forward declaration for this function. I'm going to start defining the function at the bottom. So Shift G on my keyboard to get to the bottom. Actually, I'll go back to the top. I'm going to copy this. This is on 2 lines now, so I'm going to hit Y and then down on my keyboard. This says copy the current line and the next line. I'm going to go back to the bottom, and I'm going to paste it with P. I'm going to start here. I want to declare a variable that I will ultimately return. So I'm going to say bool equal, and for now I'm going to say false. They're not equal to each other. I'm going to return equal at the bottom of this function. So I've got one exit point in this function. The first comparison that I'm going to do is I'm going to check to see if these two strings have the same length as supplied to me by the caller. So I'm going to say if str1 length is equal to str2 length, only check characters if the strings have the same length. If they don't have the same length, don't even bother checking. They're not equal to each other. If the array of characters that I'm going to check does have the same length, so the caller wants me to check the same number of characters in each of the strings, then I'm going to change my strategy here. I'm going to say that by default, I'm going to assume that they are equal to each other. I'm just going to make that assumption that they are equal to each other. I'm gonna divide you right here. Okay, this side of the room for a while. Everyone just cover your ears. What do you think? For a while. Okay. Now this side of the room, cover your ears. Yeah. Okay, what do you think this side of the room? Okay. Okay, so that side of the room said 4. Yeah, while. I'm going to go with while. Okay, thank you. So while they are equal, I'm going to start inspecting each of these two strings. I'm going to use a counter to do this. I'm going to declare this at the top of my function. I'm going to do my best to declare all variables at the top of my function. The one exception that I permit myself for this is for for loops. That's where I declare them inline. For int I always just do for int I. I don't bother declaring int I at the top and then using I later. For other things, I'm going to declare my variables at the top. So while equal, I'm going to say if string 1 at current equals string 2 at current, then they are equal. So I'm going to change that. If it does not equal, then equal equals false. They are not equal to each other. I'm always going to say current plus plus. And I will amend this slightly to say current is less than str1 length. We just asserted that they are equal to each other above that, so I'm not going to compare it to both of them. Yeah.
In Java, we wouldn't just say if the strings are equal or not. We have to use a specific function that was dot equal. Do we not do that in C because it's ultimately just a array of char?
So there is no dot equals in C, and ultimately that's actually what we're writing right now. So in Java, you had to say the string itself dot equals. You're calling a method on it. And what you're implicitly doing with dot equals in Java is that this argument to the function that we're writing right now is the thing that's on the left side of the dot. And then what's on the right side of the the dot inside that you're passing to equals as a parameter is the second argument that we're passing here, the second set of arguments. In string.java, so exercise for the reader, you can find the source code to string.java online. Just search for string.java JDK source code, and you will find a pretty massive Java program or a Java file that represents the string class. Equals is implemented exactly this way. It's just checking one character at a time. Are the two strings, do they have the same length? And then is it going through and checking every single character for equality? Ultimately, it's implemented in the same way. Does that answer your question? Okay, good, good. Okay, so we've got a string comparison function here. The key things that I want us to notice about this are that we are, again, forward declaring our functions at the top of the code. We are defining our functions at the bottom here. These are arrays of character. So we are passing the length of the array to the function where we are working with it. In terms of working with arrays in C, it's effectively the same as it is in Java. We're using those square brackets to find elements within the array. We can compare characters and primitive data types for equality with equals and not equals in the same way that we could in Java. And here we are choosing to use a while loop because this is an event-based loop. The event here is that we get to the end of the string and all of the characters are equal, or we find a pair of characters somewhere in the middle that are not equal to each other. I'm going to call this. So I'm going to go back to my main function here. My cat's name is Walter. You can insert your own cat and or pet's name here. I'm going to say bool equal is equal to string compare. I'm going to pass the first string, name. I'm going to pass length. I just assigned length right here on line 24. I'm going to say cat, and then I'm going to say string length cat. Here, I'm going to say if equal printf %s and %s are equal. Else okay. I'll give you 5 seconds to catch up here, but I'm not going to close this. I'll just make it smaller. Okay, I'm going to collapse this just a little bit. I'll go back so that you can see the bigger parts of the structure here. I'm going to compile this, clang, wall. I'm going to hit up on my keyboard here again. Up lets me recover the lines that I've previously entered into my terminal, so I don't have to retype them each time. I'm going to run strings. Franklin and Walter are not equal. Okay, good, good, excellent. I have written an equals loop. I've written an equals loop. At least I can show that things are not equal. So let's change the name of our cat here to Franklin. Let's compile it again and run it. And they are equal. Okay, so good. We have successfully written an equals loop with strings. Again, big takeaways. We're working with arrays here, so we're passing the size of the array to the function to work with. We're forward declaring our function. We're choosing a while loop because this is an event-based loop that I want to work with. I'm going to make this go back to Walter. Any questions? Any uncertainties? Yeah.
Just one question on writing the function. When we made like the if statement to see if, what was it?
I'm going to go back down. I'm going to make this big. I'm going to go back down.
Yeah, when we did the string compare, instead of doing like the if statement, why don't we just have like one line that says equal, equal sign, and then string one, bracket current, equal, string two, bracket current, because that would also basically do the check, and then it would be true or false. Yeah, just like that. Is that a bad practice, or is that?
This is not a bad practice. My strong preference is to write this because this is clever, but if I'm reading through this quickly, I don't notice that I'm actually making a comparison here. If I'm reading through this quickly, it's clear to me that there is a comparison being made here. When we're thinking about what is our compiler doing here versus here in terms of like emitting instructions, they're going to be the same. They're going to be basically the same thing. The number of operations to do this assignment and comparison is functionally equivalent to doing a comparison, an assignment, and a branch instruction. There's 3 instructions here instead of 2. But again, now we're talking about like billionths of a second. Yeah. Yeah.
Would you also need to throw a plus plus?
Oh yeah, we'd still have to have, we could even go further and say that, yes. And importantly, that's different from this, which is also valid. So I'll put it this way, and I'll leave it here so you can see it, but I would prefer to write the other one just for the sake of clarity of the reader. We are writing code that we can read later, that other people on our team will functionally be able to read later. Yeah.
How are you able to write all of this without having?
How was I able to write all this without getting a segmentation fault? That is a perfectly valid question. And part of this is I am making sure that when I'm working with these strings, I'm using lengths of strings. In this function, I have not allocated anything except for primitive types here. So I've got that Boolean and I've got an int, but I haven't allocated any arrays. I'm just reading arrays. In my main function, I'm going to scroll back up here. I have allocated arrays here on line 22 and 23, but I'm using the C compiler to basically say this is how much space you should allocate for these things because I'm using double quote strings. The important part to me to try and get out of situations where I can have a segmentation fault is to make use of lengths of arrays and respect those lengths of arrays. Segmentation faults often is kind of like array index out of bounds exception, except it's a long time after you've gone out of bounds of the array. Any other questions? Yeah.
Is it better to
That's a good question. So the question is it better to write the description of the array here, the description of the function up here at the forward declaration or down where you're actually defining the function? We're eventually going to take these forward declarations and put them in a separate file. And the separate file is the one that the reader would get. The one that's using this code is going to get this part of it. So I will always prefer to write these right at the declaration at the top of the file. And then when you have the actual definition of the function later, you aren't really obligated to just recopy this whole thing. You can either say like, look back up. That would be fine with me because it is actually the same function that you're talking about. In Java, when you have an interface, you comment the interface, and then you can use this special string for JavaDoc that says inherit doc, and it will just like basically copy paste that description or that comment. You can effectively do the same thing here, but just freehand, look up to the forward declarations to see how to use this function. Any other questions? We're good? Okay. The last thing that I want to do here is I want to write a function that's going to copy strings. Straight up, I'm not able to say name is equal to cat. Can't do that. If I do this, I'm going to save it. I'm going to zoom out. I'm going to try to compile this again. I cannot assign to an array this way in C. In Java, this would be just fine. It would be just fine. It would work. I could get on with my life and just keep thinking about writing code and not thinking about arrays of characters. In C, this does not work. I want to write a string copy function. And the way that I'm going to think about doing this is immediately, let's return an array from a function. Don't type this yet. Don't type it yet. I want to think about this. String copy, char string 1, int str1 length. I'm going to forward declare this. I'm working with an array, so I'm passing the array and the length of the array. But if I compile this, I can't assign strings this way. I also cannot return strings this way. The way that I'm going to get around this is that I'm going to use something that looks a little bit foreign. This is not something that you would ever have to do in Java. My string copy function is going to, for now, return void. It will not return anything. I'm going to change the name of this to be source. I'm going to change the name of this to be characters. And I'm going to add char target. I want to copy from source into target a specific number of characters. The args that I'm passing are source, where I'm copying from, target, where I'm copying to, and it's assumed that there's enough space, and characters, the number of characters to copy. I'm going to copy this. I'm going to go down and paste it so you'll still be able to see it. I'm going to start copying from 0 up to this thing. I'm just going to copy. We've got two kinds of loops that we could use to do this. For and while. On the count of 3, on the beat after 3, please. For or while. 1, 2, 3. Oh, yes, thank you. I got chills up here. That's really good. Thank you. So for int I is equal to 0, and I think that we can all type this in our sleep, so I'm not even going to say it. I believe that we can all just type this in our sleep. I'm going to go back to the top again, and I'm going to start calling this function. So here I am in my main function. I'm going to write here name %s cat %s \n name cat. I'm going to say string copy. I want to copy from name to cat, and I want to copy Sterlen string length name. And then I'm going to print it out again. So copy paste. I'm going to make this smaller, but it'll stay up. I'm going to compile this again. I'm going to hit my up arrow. I'm going to run this. We've done two interesting things here. One, we've gone array index out of bounds exception, but we did not get array index out of bounds exception. Instead, what we did was change the contents of a different array unintentionally. That's mistake number one. That's okay. That's okay. The other mistake that we've made here is that the string copy function has not written that sentinel character into the array. So I'm going to do two things. One, I'm going to change this so that I have number define new name size, and I'm going to make it 50. And I'm going to say char new name size. I'm going to make an array that's just big enough to copy stuff into. I'm going to go down to where I'm doing the copy. And I'm going to copy from name into new name. That'll work just fine. I'm going to change my print statement here. Whoops. To print out new name instead of cat. That's the first thing I'm going to fix. I'm going to introduce a new word for us. I'm going to use the word buffer. Buffer means different things to different people. Buffer might mean like that big machine that you push around on a floor to buff the floor. A buffer might mean if you're working in chemistry, you use a buffer sometimes to, actually, I don't remember what the last time I did chemistry was in high school. It is a word there. What is it? It's like a chemical that you have that's just to hold something, I think.
I guess when you're trying to get a salt,
A salt.
you use a acid or a base. I've heard that could, when you add on to it, or like when you add the salt, then acid to it,
Yeah.
almost always gives you,
Okay.
or it gives you a salt there.
Okay, so welcome all to Chem 1700. Okay. Thank you for that. Thank you for that. I'm going to use the word buffer frequently when I'm talking about arrays. Not arrays of strings or characters, but just arrays. And you should assume that they are synonyms here. If I use the word buffer, I mean array. I've created a buffer here that has 50 bytes of space, 50 characters of space in it. I will compile this again. I will run it. But we still have this kind of like extra garbage here specifically. Here, we did not have any weird character changes like we did this last time. We've not gone past the end without being told, but we still have this extra garbage at the end. So I'm going to go down to the bottom, back to here, and I'm going to change to declare my loop variable outside of my loop. I can't just do this. I will do this for the sake of clarity. Then I'm going to say target at I is equal to the null byte. We must do that so that printf knows where to stop printing. If printf does not see that null byte, it's just going to keep going, and whatever numbers happen to be in it after the characters that we've copied, they're just going to keep showing up. So we must add that new null byte at the end of this string. We still get this kind of garbage output on the first line here because we didn't actually put anything in there. We didn't initialize this array to anything. My best practice advice before, I'm going to go back up to the top, was you should initialize your arrays to have a default value. It would be reasonable for you to put 0 here. I intentionally did not do that so that we could get this kind of weird looking output because we did not put that null byte in. Initializing everything to 0 means all of them are null bytes. And so we'd never notice that if I did that at the first time. I would still give you this advice. Initialize it to 0 by default so that you don't get this weird output. So if I compile this again and I run it one last time, now we get something that's kind of like sort of normal looking. Okay, I'm going to hold here for questions, and then I want to get moving on to something else. Yeah.
There's a function strcpy. We basically just read what that function is doing.
Yes. There's a string library called string.h that has strlen, which is string length. It has, I forget what actually the string equality one is, but there's a string equality one, and there's a string copy, which is strcpy. Yes, they exist, but part of the purpose here is to see what's going on under the covers. We can blindly use them later, but for now, I just want to be able to see what's happening. Yeah. There was another question. Yes, of course. I could have used the character. Yes, thank you. I could have used characters here. That's what you're saying? Yeah. I could have done this as well. Any other questions? Yeah. Is yours supposed to be doing copy? Sorry, I'm misunderstanding your question. What do you get?
It's not even copy. It still says Franklin.
It still says Franklin and Walter. So I will point out again some of the changes that I made just in case. I changed both print statements to print out new name. And my string copy function, I'm passing to it as the second argument, new name. I would also suggest that if you haven't compiled it again, that you recompile it. Can I look at your code?
Sure. What do you want to look at? Which part?
So show me your main function. So you still have cat here in printf. So in the printf here, I have new name. Yeah. Okay. So if you're still having trouble after class, just come and see me. Yeah. It should work though. It should work. I will always post these examples for the record to the course webpage after class. So if it doesn't work for you, then you can at least make comparisons to see what you've got and what I've got to see how they're different from each other. Okay. Okay. I want to leave this because I want to get to the last thing that that we're taking a look at here for just before we get to assignment stuff. So we're doing a lot of stuff here. We're declaring a function that takes an array as input and returns an integer. We're declaring a function that takes two arrays, and then the input also includes the length of the arrays that we're working with. When we're working with arrays in general, we're wanting to pass the length of the array to make sure that we've got that. The other thing that we're doing is we've added this new kind of way to call functions that accepts an output parameter. The output parameter here is we've got to return something from the array, but from the function, but in this case, we cannot return an array, so we pass to the function where we're going to copy something to. In the code example that we're looking at here, we've declared the array and initialized it in the main function, and then we're passing it to the function that we are copying into by passing it to an output parameter. All right, so I'll post this up to the course webpage so you'll have a copy of this so that you can compare what you've got to what I've got. Switch topics just a little bit here. Previously, we got input from standard input with that function getChar, but the assignment that we're looking at right now kind of requires us to do line-based input. We could do all of this with getChar, but it would be super painful to do this with getChar. So we're going to use something called fgetS. Working with whole strings with getChar is going to be pretty challenging, so we're going to use fgetS to do this. I say this as fgetS. Some people say fgets. Say it how you want. I think I'll understand what you mean if you say fgets, but I say fgetS. But then I also say fget sometimes, so forgive me if I change stuff. fgetS takes three inputs. It takes the buffer that you are copying into, the character array that you're copying into, the number of characters that it's allowed to write into the buffer. This part, the buffer that you declare here, must be at least as big as this. It has to have enough space to have all of those characters in it. The other thing that it takes as input is a file pointer, and this is where it's getting input from. I'm going to start writing some code that does line-based input on standard input. I'm going to start typing this from scratch. I'm not working from strings anymore. I'm going to start a new file here. And we're going to go through a process of getting some line-based input on standard input. So I'm going to switch back to my terminal. I'm going to quit strings.c. I'm going to copy that template again. I'm going to call this one lineinput.c. I'm going to first declare an array, a string, that I'm going to be able to copy into. fgetS takes three arguments: a buffer, the thing that I'm copying into, the number of characters that it's allowed to copy, and where it's copying things from. So I'm going to number define. I'm going to do names here again. I'm not imaginative. I'm really sorry. I'm not imaginative, but we're going to get a functional example here. I'm going to say name length is 50. There's no semicolons here. It's just 50 digits, no semicolons. We're going to say char name length. This is going to be an event-based loop. I'm going to keep reading input until there is no input left to read. So I'm going to say while, and then I'm going to say f get s. What I'm going to pass to it is name. I'm going to pass the size of the buffer. And I'm going to pass this special thing std in. I didn't declare this variable anywhere. It is available for me to use from stdio.h. I just get this for free. I'm going to say while f get s does not equal, and I'm going to expand this just small for just a second. I'm going to expand this side big, and I'm going to say man3 printf. I'm going to use the manual page to tell me a little bit about printf. I'm specifying 3 here. Section 3 of the man pages is functions that you can call. If you don't specify a section, it's going to tell you about the program, the command line program that's called printf, but I want to know about the function that's called printf. So I'm specifying section 3. I'm really sorry here, f get s. That's the one that I want. So f get s reads in at most 1 less than size characters from stream. Reading stops after an EOF or a new line. A terminating null byte is stored after the last character of this, this thing. F get s returns s on success or null on error or when end of file occurs while no characters have been read. So the key word here is it's going to return null when there's no more input for me to be reading from this thing. So my loop here is going to be while f get s, I'm passing to it the buffer, the number of characters that it's allowed to read, is not equal to uppercase null. In Java, null is lowercase null. In C, it's all uppercase null. Null is just 0 in C. That's all it is just 0. In the same way that 0 is false, null is also just 0 in C, but we get the special word for it. So while f get s name length stdin does not equal null, I would like to say printf. Your name is %s\n name. I'm going to make that smaller. I'm going to quit my manual page here. I'm going to say clang wall line input -o line input. I'm going to run line input. F get s is now patiently waiting for me to type something in. So I'm going to type something in. And I'll press enter. Your name is Franklin. I'm going to type in Walter. Your name is Walter. Okay, this is really exciting. I know it's super, super exciting. F get s is doing effectively what we did with our string copy function. It's reading from standard input. So here on my keyboard, it's reading inputs until it hits a new line character. So I hit enter on my keyboard. As soon as I hit enter on my keyboard, it's not going to continue to read up to 50 characters. It's just going to stop working at that line, put that null byte at the end, and then print out, and then go back to getting more input from standard input. Yeah. Does it reset the array? That's a good question. So does it erase everything that's in the array after, or once you start? It does not do that. So if I were to do something like, I'm going to do something kind of dumb here, but I'm going to say printf, eighth character is %c name at location 7. Yeah, off by 1. So Franklin is 8 characters long. Walter is not. I'm going to hit Control D on my keyboard to end input to say there's no more input, stop reading. I'll compile it. I will run it. I will say Franklin again. I will say Walter. The 8th character has now been replaced. I'm going to say Franklin again. I'm going to say Tom. The 8th character is still N. It doesn't erase everything. All it's done is put the new line, or the null byte at that position that ends the string. The other thing that I want to do here very quickly is kind of the terminal part of this. I would like to redirect to standard input for this program. I've got a program here that is reading from standard input. I'm going to edit a file here called names.txt. I'm going to say Franklin, Walter, Tom. I'm going to save this. I'm going to say line input. To read from a file with what we've got so far, we do not need to open files. All we need to do is redirect standard input. If I say names.txt here, so less than symbol, it's going to take the contents of this file that's called names.txt, and it will become the standard input for that file. So if I hit enter here, we're going to get Franklin, Walter, Tom. Then the last thing is there's a blank line in this file. So we read one extra line that has an extra nothing in it, and it will print that out for us. All right, I will post this example to the course webpage. I'm going to switch over here. I will stay after class for questions about assignment 1, but I will also just include this as the very first thing that we do tomorrow. But at this point, you should be able to declare, initialize, and use strings in a C program idiomatically and safely. You should be able to pass to a function a return and then return a string from array as an output parameter. You should now also be able to get line-based input from standard input with fgetS. Thank you all, and I will see you tomorrow. Bye, everyone.